Hi everyone. Today we are going to look at again the difficult questions taken from a different past paper. Here again we are going to use basically the AS level chemistry paper. The paper is going to be like paper 1 2. Going to use paper 1 2. Yesterday we have seen paper 1 1. This is again May June 2024. So that's what we are going to do. Okay, let's do the first question. The first question is about free radicals. Free radicals, they should have at least one unpaired electron. So how to solve this question? I need to first draw the dot cross diagram, or else Lewis dot cross structure. Only the outer shell electrons I can represent. The first case I have Cl. Cl, it has 7 electrons in the outer shell. 1, 2, 3, 4, 5, 6, 7. So it's a free radical. Oxygen, I have 1, 2, 3, 4. There are 2 unpaired electrons. If I write this electronic configuration, 1s2, 2s2, 2p4 I will get. 2p4, if I do the box diagram, 1, 2, 3, 4. So you have 2 unpaired electrons. That's why I have. So it's also a free radical. Then when I go for Cl minus 1, 2, 3, 4, 5, 6, 7, there is an 8th electron. So it's not a free radical. Then oxygen 2 minus 1, 2, 3, 4, 5, 6, 7, 8 electrons. It's not a free radical. Again Cl repeated, O minus. Let us talk about O minus. O minus 1, 2, 3, 4, 5, 6, 7. That is O minus. So it's a free radical. It's a free radical. This is a free radical. This is a free radical. So from this I can find 1 and 3 are correct. But still the fourth choice, Cl plus they are talking about. Cl plus means it lost one electron. So 1, 2, 3, 4, 5, 6. It may show it's like all paired. Let me draw the box. So outer shell is 2s or else 3s 3p, right? Okay. So 1 2 electrons, then remaining 5 electrons, only we have 4 now. 1 2 3 4. So now you have 2 unpaired electrons. These two are not paired, they are unpaired. So Cl plus is a free radical. I hope you understand. The same way O2 plus. Let us talk about O2 plus. O2 plus number of electrons will be 4, correct? Because oxygen totally 8 electrons, in the outer shell 6 electrons. Now the number of electrons in the outer shell is 4. So when I consider 4, 2s and 2p. 2s 2 electrons. 2p there are 2 unpaired electrons. So again it's a free radical. So this is also a free radical. So the choice is A. So the basic idea for solving this question is unpaired electron, and after that trying to draw these kind of electronic configuration. Then from that, if you find unpaired electrons, then that is the free radical. The next question, which statement is correct? This is from inorganic chemistry, and as well some parts from the bonding and the structure and bonding topic. Aluminum chloride has a giant ionic lattice Al3 plus and Cl minus ions. No, it's not so. Aluminum chloride is simply a covalent material, and this covalent material can connect with coordinate covalent bond. It can dimerize Al2Cl6. So this is not correct. Sodium chloride dissolves in water, forming hydrogen chloride and sodium hydroxide. That is not true, because sodium chloride not reacting with water, it only dissolves in water. If suppose water becomes a reactant, if it undergoes hydrolysis, then this statement will be true. But it is just dissolving in water, it will dissociate into sodium plus and Cl minus ions. So this is wrong. Strong covalent bonds in silicon chloride. Silicon chloride has covalent bonds, but I cannot say it's a strong covalent bond, and as well it prevents it from reacting with water. It is not true. Silicon chloride reacts with water. It undergoes hydrolysis. That is also wrong. Obviously D will be correct, and I know that phosphorus 4 chloride, when it is added to water, it results in HCl, so which can dissolve and dissociate in water, and it can conduct electricity. So D is the right choice. When I move on with the third difficult question in this paper reported by the examiner, is which statement describes the property of ammonium ion? Aqueous ammonium ion is a weak Bronsted-Lowry base. Base is acceptor of proton, but ammonium ion is a donor of proton because it is NH4 plus. It already accepted, so it cannot further accept a proton, so it's wrong. Aqueous ammonium sulfate reacts with dilute hydrochloric acid to make ammonia gas. That is also wrong. Normally ammonium salts, which are solid, reacts with sodium hydroxide to produce ammonia gas. That is the reaction we know. It won't react with HCl to give ammonia gas. That is also wrong. Ammonium ion has a pyramidal shape. That is completely wrong. Ammonium ion, which has 4 bond pairs, so it should be tetrahedral. It's not pyramidal. So this is wrong. Then the 4 NH covalent bonds in ammonium ion are identical to each other. That is true. Choice D. The fourth question. It is little related to stoichiometry. Z is a gaseous hydrocarbon which has density 3.50 grams per centimeter cube under room conditions. Z reacts an excess hot concentrated KMnO4. So only one type of carboxylic acid is formed. Hot acidified concentrated KMnO4 will break the double bond. So it produces different products. When the double bond is broken and only one type of carboxylic acid is formed, means the double bond looks like this. It's the double bond. It has something else, and the double bond breaks here, so that the COOH and COOH, and you are having a equal group on the side. That's what they are saying. So you get RCOOH. This is what the idea. So how to find out? First I use this density to find out the molar mass. So when I use this density to find out the molar mass, what it says, 1 centimeter cube of this hydrocarbon is equal to 3.50 into 10 to the power negative 3 grams. Therefore 24,000 centimeter cube of this hydrocarbon. So it will be, when I calculate, I get 84 grams, which is 1 mole of it. So now let us find out the molar masses of all these 4. Butene, it is nothing but C4H8. C4H8, 4 12s are 48 plus 8, which is 56. It's not correct. Then other 3, when I calculate, I will get 84 84 and 84. Okay, out of these three, who will give me a single carboxylic acid? So I need to write the structures. Let me write 2,3-dimethyl-butene, C double bond C. This is butene. So butene 2,3-dimethyl. Now hot KMNO4 breaks here. But what you will get, you don't get CH here. You have C double bond O. So C double bond. So you will get a ketone, not the carboxylic acid. So choice B is wrong. It may look at the first sight, okay, I got the answer. But this is a wrong answer because they are talking about carboxylic acid. They are not talking about ketone. So this will result in ketone. So let us look at hex-2-ene. Hex-2-ene, CH3, CH double bond CH, CH2, CH 1, 2, 3, 4, 5, 6. So again I have the same flavor, CH double bond CH. Okay, so here I break, I'll get a acid, but this is a 2 carbon acid, this is a 4 carbon acid, but they are talking about only one type of acid. So now obviously the last choice will be the right choice. Let me verify that. CH3, CH2, CH, double bond CH, CH2, CH3. So now I break it here. So I get 3 carbon carboxylic acid, 3 carbon carboxylic acid. Yes, I am sure D is the right choice. I don't know, this set has all the correct choices as D. Almost out of 5 questions, 3 questions we got D. D for difficult it seems, I don't know. Right, next is question number 40. Question number 40 is also a little difficult. It's little confusing, nothing else. They're talking about X reacts with acidified K2Cr2O7. Always acidified to K2Cr2O7, basically it reacts, it oxidizes primary alcohol and secondary alcohol. That is what we learned. Please be careful. So, and they are asking what is the compound X. But the data given is for Y, which is formed out of X using K2Cr2O7. So X reacts with K2Cr2O7, the compound Y, and here I have got the choices like alcohol and acid and a ketone. So normally a primary alcohol can be converted into a carboxylic acid by the K2Cr2O7. A secondary alcohol can be converted into a ketone. This is what I know. So from this I eliminate choice C and choice D because these two are the products. They may be Y, they are not X, because they are asking about X. The choice is having some kind of Y. No, I am not going to consider them. Now I am going to consider propane 1-ol and propane 2-ol. When I consider propane 1-ol and propane 2-ol, which is going to be, right? When I look at this, I have a broad band here, which is at 3000. So I am having something here, 3000. So I have a carboxyl OH may be there. Then I have another sharp peak here, 1700. So 1700 this area. I am having a carbon double bond O. So I have a carbon double bond O and I have a OH group. So Y is the carboxylic acid. When Y is the carboxylic acid, X should be primary alcohol. So propane 1-ol or propane 2-ol, propane 1-ol is the primary alcohol, so that is the correct choice. So I hope these clues and tips would be helpful for you to crack these kind of questions. I will continue with the other videos with the next set of questions. Thank you for watching.